So anyway, I'm not going to talk about goal setting. I'm going to talk about a pet peeve. It's going to be the way in which the social sciences, at least so far as I know, actually discourage the building of good theories, paradoxically by making it too much of a primary. And so what I'm going to do is defend the inductive process, which is also consistent really with the history of science in general. Oops. So let's start with bad philosophy of science. And one of the biggest villains in my mind is Karl Popper. Popper rejects induction. He rejects objective concepts. He rejects causality. He rejects the positive approach to finding scientific discoveries, and he says all we can do is make up random, emotionally based guesses and then try to disprove them. To me, this is a disaster because you can't move science forward by proving that something is not true. You have to present positive evidence. And in the social sciences, what we see now, at least in the journals that I know of in management and biopsychology, is theory mania. So here's how it works. You want to get a paper published, you make up a theory, even if you didn't start with one. Maybe you bring in 3 or 4 theories. You pretend to deduce hypotheses from those theories, and then you test them and get the results, and that's the end of the process. So that's in the experimental journals, or we have theoretical journals like AMR. I don't know a single AMR article that's ever led to the development of a validated theory, because again, where are they starting from? They're starting from theory to develop theories, not from integrating data. And it makes for, people have told me this personally in private, makes for incredible hypocrisy in the publication process, because everyone admits they have to make up half the stuff to get a good deduction, and of course the stuff that doesn't come out gets left out. And so theories are taken sort of at random and made to look good, but they don't lead to anything. And I even heard a worse story that if you had published an article in the Academy of Management Review, which is a theory journal, then you tried to test it and submitted it to the Academy of Management journal, it was rejected. Said, you've already done it. So why do I want another study? You've already done the theory in the theoretical article. So they're also opposed to constructive replication. Typically, unless you do something that's really a new extension in some radical way, they won't publish it. So by this method, goal-setting theory would never have been developed, because we had 400 studies. Who would accept 400 studies on one subject today? So my view is that if you look at the history of science, and also if you understand what deduction is, that induction is the way to build scientific theories. Now let's look at the most popular example of a syllogism that you get in all beginning logic courses, and ask ourselves what makes that possible. So it's the normal one, Socrates is a man, all men are mortal, therefore Socrates is mortal. Now observe that the second premise is inductive, because you had to know that all men are mortal before you could make the deduction. So in reality, induction precedes deduction. Even among, and I'm not against deduction, but you have to have induction before you can form the premise that you need in induction. So what would be the processes one should use to develop sound theories if the journals would in fact, allow it, and I'll give you some possibly good news about that in a minute. So the first thing to do is clarity of concepts. Now, I've been a reviewer for about 40 years. I've probably reviewed 1,000 manuscripts for various journals, many, many different journals. I'd say 95% of the articles suffer from conceptual confusion, just in the basic concepts. And I'll give you an example from the last IO psychology meeting, which I wasn't reviewing, but it was poster sessions. And this one poster session had about 6 different articles on engagement. So I'd sort of heard of this, but I didn't know much about it. So I went up to the first person. I said, "What's engagement?" They said, "Oh, engagement is energy." I said, "Oh, that's interesting, because we already have a concept called energy." I went to the next person. Engagement is involvement. I said, "Well, that's interesting. We already have that concept." I went to a third one. Engagement is the score you get on the scale. Then I went to the fourth one and said, "Well, I've used this scale, but this scale has been really criticized, so we're using something else." So I finally said, "Do you guys realize there's 6 of you talking about the same thing, but not the same thing? Have you ever thought of getting together and discussing what engagement actually means?" And they said, "No, we never did that." And I don't think they were going to do it at the end of the poster session. But this is typical. Another form in which you see this, almost 100%, you have a concept with a scale. The items in the scale have nothing to do with the title of the concept. Or the items relate to about 4 separate concepts that are not related to one another. And you ask them, "Well, why did you do this?" He said, "Because Jones and Smith used it." So this is a commonly used scale. So the defense of this is the fact of conformity to another group, not looking at reality and trying to find an objective, meaningful definition. And there's many examples of this in the field. Emotional intelligence, I think, is an example where if you started looking at the scales people made, which were not just one set of scales, but a whole bunch of different scales, they ended up including every concept in organizational behavior. And of course, that's a great variable, because it includes everything we know, but it makes the concept meaningless. And I think what the concept should have meant, if it was to make any sense, would be something like introspective ability concerning your emotions. Or you could say introspective ability concerning your emotions plus the ability to read other people's emotions, and stop right there. Now that would be okay, but that's not what they did. So you can't, it's mind-boggling. So conceptual clarity is extremely rare, and you can thank Popper and his ilk for saying, along with many other philosophers of science, all definitions are arbitrary, therefore all concepts are arbitrary, so you can call it anything you want. You can't progress in that manner. Imagine Newton saying, well, gravity could be the attraction of big objects, but it also could be good feelings between people who attract one another, and it could also mean certain animals are attracted to other animals, and it could mean also sadness because of a grave face, and that's gravity. Where would physics have gone with that kind of conceptual chaos? Fortunately, Newton didn't do that. So clear concepts is the first starting place, and you have to think not in terms of what do other people say. You have to think, look at reality and say, what facts of reality make this concept meaningful and possible, and you tie it to reality. Leadership is another good example. Leadership's a valid concept, but one writer who was very famous in the field, in one book said in the introduction, I found 200 definitions of leadership, so I decided not to define it. And then he proceeded to write the book. So This kind of stuff goes on all the time. Second thing that's needed in developing good theory is collecting a lot of data. And that's just not one study and you're finished. That's not hardly even a beginning. That's just saying a hypothesis now looks plausible. Newton gathered a great amount of data when he developed his laws of gravity. He just didn't make it up out of his head. And he didn't just copy stuff from Galileo and others. He really did a lot of work, data gathering, to establish the generality of his formulas. So, and you want generality across different kinds of situations, across subjects, across tasks, across situations, laboratory and field, males and females, US versus foreigners, adults versus children, depending on how far you want to generalize. So it means a lot of basic work in data gathering if you want to, and I don't have an answer to say, well, how much? Nobody knows the answer to that, but at least you know you can't do it in a few studies. Hertzberg's theory was based on 2 studies. If you're my age, you would know all about that. And immediately was attacked as having methodological problems, and most of it, except for the emphasis on the importance of work, most of it fell apart. And he got furious at anyone who disagreed with him. So it didn't grow because he stopped too soon. The next thing you want to do in building a good theory is establish causal mechanisms. Now you don't have to establish all of them, but at least establishing some causal mechanisms makes it more plausible. Take something like boiling water, which is from, I guess, chemistry or physics. We know water boils at 212, but then we do studies and we find out it changes with sea level. Then we do some more studies, we find out it changes with the purity of the water. Okay, we've moved science forward. So let's say at pure water at sea level boils at 212 Fahrenheit. What is that Celsius? Is that 100? 100. Now, what would be some causal mechanisms? I think one of the first things they learned was that boiling makes the molecules move faster. That's not the final answer, but that's a causal mechanism. So we've moved science forward. It's not just a finding. We have at least one causal mechanism now. You could ask, well, why does heat make molecules move faster? I actually don't know. Maybe physicists do. But then you've got to a deeper level. So I think it's very important to have some knowledge of causality when you formulate theories. Not necessarily the full story, but some causal mechanisms involved. Gives you more confidence because you have more knowledge about how it works. Then you want moderators. And a moderator is another word for limiting condition, which is another word for interaction. All means the same thing. I gave on a doctoral student exam one year, tell me the difference between a mediator and a moderator. None of them could do it. I think they probably could now, but they couldn't. So let's go with Isaac Newton as an example, because you're probably familiar with that. Newton's laws are quite accurate for big objects, visible objects, within a certain range of error. Now, if you want to send up satellites where you don't want the exact time of when they're going to get to a certain place, you have to adjust Newton with Einstein's equations, which they do. So you could say Newton was correct within a certain range of error, but there's a certain correction needed by Einstein's theories to make it more precise. And it's also not valid for particles you can't see, like atomic particles. It doesn't work with atomic particles. It's a whole other theory. Einstein wanted to integrate all the different theories of attraction, and he couldn't do it, and no one has yet. And many people view moderators as a disaster because it proves you can't know anything for certain and so you should give up science. But what it actually does is it moves science forward. When you find a limiting condition, you've moved science forward because you've learned more. You know better when it's going to work and when it isn't going to work. That gives you more knowledge than when you started with your generalization. So it's a very positive thing to find moderators. Another thing is that theory building, in most cases, takes a long time. Goal-setting theory, when I first was willing to call it a theory with Gary in 1990, 25 years of research by us and others. And we're just publishing a new book together, which is, many of the authors are here. The field was so big, we asked people like Mia and others to write guest chapters, 37 chapters with 70-some authors. And we're still not finished. We're still extending and expanding the theory. Now, that's not a disaster to us. This is a good thing, because we're learning more. And every time we learn more, we can make more precise predictions and more precise applications. So you can't do this in a study like a journal would require. Even 2 studies or 10 studies, you need many, many studies, and journals won't accept those kind of studies unless it's a real big extension from the original. So what are some examples of theories that have been developed in this way? Certainly goal-setting theory. I can't lie. We did it pretty well. Social cognitive theory of Bandura. By the way, the discovery of self-efficacy was partly accidental. He was studying the cure of snake phobics in the laboratory and found out people increased their confidence, and that concept of increasing task-specific confidence had wide application, and that was the beginning of the building of self-efficacy theory. And then we brought in modeling because they observed models carrying snakes too, and modeling became part of social cognitive theory, and it developed heavily by induction. Another one was cognitive behavior therapy, was discovered partly by accident by Aaron Beck. These 3 theories, by the way, are discussed in an article in Journal of Management I wrote in 2007 on the need for induction. And you might be interested, this did not go through a review process because it wouldn't have been accepted. It was taken by the editor directly from me. He didn't send it out to anyone. He said, I'm publishing this. So thank you for him. So what does it mean to develop theories without making Popper feel you guilty because something might not come out? And I think the concept here from Ayn Rand is good. A contextual certainty. Contextual certainty means you have a lot of data, it's integrated, you've eliminated contradictions, and it accounts for all the data you've gathered so far. That's contextual certainty. It's not like a message from God where he says, here's the truth, and that's it. Science is not like that. It's an incremental process. So when you have developed a lot of data and integrated it, eliminated contradictions, looked for moderators, mediators, you could say, I have contextual certainty based on the knowledge gathered so far, and then I'm free to revise, refine, enlarge as more data are gathered, and it's not a threat to science, it's a complement to science. If we discover new things, we've moved our knowledge forward. And that's the way the history of science has worked. So, could the journals do better? Well, I have possibly good news. The Academy of Management may be approving a new journal for inductive research. It would be a miracle if that goes through, which is a very good thing. I don't know how well it will operate in practice, but it's deliberately to get around this problem, and it'll be a big step in the right direction. I don't know if these same problems, by the way, occur in other fields that I haven't read about, but I'm just telling you in IO psychology and management, it's terrible how it works. Now, what would a journal like this, inductive research, require? I hope I'm on the editorial board. I hope I get, because I did write a letter of support for the idea. And here's what I would look for. Number one, you could pose the article simply with questions. I want to know what happens when you do this. I once published an article like this in Journal of Applied. It would never be accepted anymore. I said, I'm going to ask 5 questions in these studies, and the editor, the old-time guy my age, accepted it. They wouldn't do that now. So you can have hypotheses, but don't need theories. Short introduction. You could say, I'm just going to try some things, but I know what's been found, so I'm not going to repeat what's been found. And then the decision would be, have you moved the science forward in a non-trivial way from what you found? And if you want to discuss theoretical development, you do that in the discussion, not in the introduction. So that would be the way I would like to see it run. I don't know if John Hollenbeck will probably be the editor if it comes. I don't know if he'll agree with that. I'd also insist that the articles deal with causality as a genuine, important question. I'd want to accept articles of replication with a systematic variation. And I'd want to see integration of this finding with what's been found before and see if does it add up to anything. Does it move things forward as a whole? So I view, I wanted to mention one more example. I've known Ben Schneider for about 40 years, and his interests are totally different than mine. So I haven't kept up with his work, but I've heard of it, and until today I didn't see it presented as a package. But from what I observed, I would call this a very good theory-building process that he went through. He had mediators, he had moderators, he had clear definitions, he had lots of data from many different sources. That's exactly the way I think theory should be built. So anyway, my compliments. And this is the first time I've really heard the full package. And I think Michael Friese isn't there yet, but I was talking to him. I think he has enough data that he could be there, because he's gathered a lot. And if he puts it together, maybe he'll have a theory of the kind I'm talking about also. So what I'd like to see really is a major revolution in the way journals, at least in the fields I know, operate, because I think not only does it's actually ironically anti-theory because it's so pro-theory, because it's putting theory before the data. So it actually prevents the building of good theories. And if you look at the field, there aren't very many good theories that are really well developed. There's things people call theory, but they're not well developed in the criteria that I talked about. So I'm hoping this will change. So that's really all I want to cover, and I'm hoping for change in the social science culture. I don't know about those of you in other fields if it's that bad, but I hope not. So I think I'm going to stop there. I have to change my identity, but Abby's going to introduce my new self.